Let us go for foundation chemistry. In the foundation chemistry, we'll take a naming of organic compounds. We'll go for organic compounds. So first we'll see what is compounds. We'll see. First we'll go for compounds. Compounds in the sense different and more than one element should be there. Different elements should be there. Different elements is there in the sense that we can say compounds. Okay. So different elements is present in the sense that we are saying compound. In the compounds, several classification is there. One we will call it as inorganic compounds. One we will call it as organic compounds. So, which we will call it as inorganic compounds, which we will call it as organic compounds, we will see. For that, how many elements are discovered so far we will take. So far, 118 elements are discovered. 118 elements are discovered. In these elements forming several types of compounds. For example, water, H2O, sulfuric acid, H2SO4, carbon dioxide, CO2. Like this, many compounds are there. All these compounds are called inorganic compounds, we can say. We have to call them as inorganic compounds. So, other compounds are there. What are the other compounds in the sense? Hydrocarbons will take. Hydrocarbons. These are one compounds. Hydrocarbons are some compounds. In the hydrocarbons, what are the elements present in the sense? Carbon. Carbon is present. And this hydrogen is present. So, hydrocarbons in the sense, in these compounds, what are the elements present in the sense? Carbon atoms present, hydrogen atoms present. These compounds, we have to call it as organic compounds, we have to call organic compounds. Now, if we take crude oil contains hydrocarbons. Crude oil, petroleum products mostly hydrocarbons. So hydrocarbons, those compounds are called organic compounds, we can say. And now we will take derivatives of organic compounds. Derivatives of hydrocarbons will take now. Derivatives of hydrocarbons. Okay, derivatives of hydrocarbons will take. Derivatives of hydrocarbons are also called organic compounds. So, what is derivative of hydrocarbons? Derivatives of hydrocarbons means what? In the hydrocarbons, what is there? Carbon and hydrogen is there. Carbon atoms and hydrogen atoms are there. Now, remove some of the hydrogens. Add some other elements. The obtained substance is called derivative of hydrocarbon. Why? Because it is from hydrocarbon, therefore it is called derivative of hydrocarbon. Okay, so derivatives of hydrocarbons are also called organic compounds. So, derivatives of hydrocarbons we are saying now, what is example? For example, we'll take like this, we'll take one reaction like this. Okay, this is CH4 we have taken. In this compound, carbon is present, hydrogen is present. So we are converting this compound into like this in the chemical reaction. In the H nu means sunlight. Okay. Now here one in this CH4 one carbon is there. Here also one carbon is there. Here 4 hydrogen atoms are there, but here 3 hydrogen atoms are there. Therefore, we are removing one hydrogen. Here Cl is present, here Cl is not present. So we are adding one Cl. Therefore, we are replacing hydrogen by Cl. Therefore, we can call it is a derivative of hydrocarbon. Okay. These derivatives of hydrocarbons also called organic compounds. So, which are organic compounds? Hydrocarbons and its derivatives are called organic compounds. In the organic compounds, how many are there? Plenty of compounds are there. Organic compounds, plenty of organic compounds are there. Therefore, it is separately studied under organic chemistry. So, now, how to name these organic compounds? That we'll see. How to name these organic compounds? Okay, that will take. For naming these organic compounds, one nomenclature is introduced, that is IUPAC. IUPAC nomenclature is introduced. Abbreviation of IUPAC is International Union of Pure and Applied Chemistry. IUPAC abbreviation International Union of Pure and Applied Chemistry. This IUPAC nomenclature is there. And another nomenclature is there. What is that in the sense? Commonly followed, commonly saying names. Commonly saying names. That is called a common name, we will say. These two are there. Other than that, commercial names also there. Commercial names also there, we can say. Okay. So generally, which is followed in the sense common names and IUPAC names will be followed generally. Okay. So now we will see. Now we will see the nomenclature. Before seeing the nomenclature, we will take the organic compounds. We will take organic compounds. We will take. In the organic compounds, if you see, plenty of organic compounds are there. To study them easily, we have to classify them. To study the organic compounds easily, what we have to do? We have to classify them. What is classification in order to make them study easily? So we have to group them separately. Organic compounds, we have to group them separately. How to group them separately? Based on their characteristics, based on their properties, based on their structures. Based on their structures, based on their properties, based on their characteristics, we can classify the organic compounds into many categories. Okay. That classification we have to see, that we will see later. Now we will take one group, we will take in the organic compounds. Particular group we will take. Particular group is called what in the sense? Alkyl. It is one group in the organic compounds. This alkyl, here alkyl in the sense, here one dash will be given. One dash is given in the sense, this is indicating one bond. It is indicating, this is indicating what in the sense? One bond. One bond. One bond is given in the sense, this side, this right side, something has to come. That is a meaning. Something is there. That is a meaning. So, this alkyl is there. No, what does it indicate? This alkyl is indicating it is a prefix word. It is a prefix word. That's why we are saying right side something is there. We are saying this alkyl is the prefix word. This one bond we have written, and the right side something is there. We said, we are saying that means this alkyl is the prefix word. So, in this alkyl, this alk is there. What is the meaning of this alk? What does this alk indicate? What does this alk indicate? This alk indicate number of carbon atoms. Number of carbon atoms in the given alkyl group. So what does this alk indicate? This alk is saying about what? It tells about number of carbon atoms present in this alkyl group. That's what this alk says. Sir, Number of carbon atoms in the sense, for specified number of carbon atoms, alk is having certain specific name. If number of carbon atoms is 1, this alk is giving specific name, that is meth. If number of carbon atoms 2, this alk gives specific name eth. 3 carbons prop, 4 carbons but, 5 carbons pent, 6 carbons X, 7 carbons ept, 8 carbons oct, 9 carbons non, 10 carbons dec, like this. 11 carbons undec, 12 carbons dodec, etc. Like this. So what does alk indicate? It indicates number of carbons present in the alkyl group. That's what it indicates. Okay. So this this YL, here YL is there. It does not indicate anything, but it says that this hyphen means it is a bond. This bond says that this group is not one molecule. Some other thing is bonded. This group is bonded with some other thing. That's what this bond indicates. Okay. Now, what is the general formula of alkyl? That we'll see. General formula of alkyl is CnH2n plus 1, and one bond we have to give. That means it is attached to some other thing. That is the mean. It is, this group is bonded to some other thing. Then only this whole together is called molecule. This group alone is not called molecule. So general formula of alkyl is CnH2n plus 1. Like that we have seen. This N always 1 or greater than 1. This N always 1 or greater than 1. Sir. And this N takes whole number values. That means natural number values starting from 1 and goes on 2, 3, 4 like this. Integers only it will go. It is not fraction. N is not fraction. Okay. If we substitute N is equal to 1, what we will get in the sense CH3 we will get. Now in this CH3, how many carbon atoms are there? Means one carbon is there. One carbon in the sense, in the place of alk we have to say meth, we have to say. In the place of alk we are saying meth. In the place of alk we are saying meth. Then what is the remaining letters are there? Means YL is there. That YL we will write, therefore the name is methyl. So CH3 is there, means what is the name we have to say? Methyl we have to say, as per a methyl word, methyl name we have to say. Okay, name is methyl. Set. Now we will say N is equal to 2 we will take. N is equal to 2, if you substitute here, you will get C2H5 you will get. This C2H5 is the condensed formula. Now we will write it is condensed one. We will write that means we will split this and we will write here 2 carbons are there. The 2 carbons let us write separately. Then between carbon atoms let us give single bond if it is coming under this general formula. This general formula if you take, then between carbon atoms we must give single bond. Then hydrogens. Hydrogens we will give to carbons. Hydrogens we will give to carbons like this, we will distribute. 3 hydrogens to this carbon, 2 hydrogens to this carbon, like this we have distributed. Hydrogen makes single bond, we know. Hydrogen makes single bond. Hydrogen always makes single bond. Okay, hydrogen makes single bond. Carbon valency 4. So carbon can make maximum 4 bonds. And in most of the compounds, if you see, in the organic compounds, if you see, carbon will form 4 bonds. That is normal. That is minimum as well as maximum. Okay. Normally, if you see in the organic compounds, in the molecules, organic molecules or organic compounds, normally in which carbon will form 4 bonds. Okay. Normally, if you see carbon is forming how many bonds? 4 bonds. In that exception is there. What is the exception? Suppose it is converting into some unstable species. This compound is converting into unstable species means in that carbon will not have 4 bonds. Okay. In the stable means carbon will have 4 bonds. So, carbon compounds, inorganic compounds also there. Inorganic carbon compounds also there. In that case, carbon need not have always 4 bonds. Less than 4 bonds also possible. 4 bonds also possible. Okay. But organic compounds, normal compounds in the sense carbon will have 4 bonds. Okay. Because valence is 4. So this carbon, if you see, this carbon is having 4 bonds. Therefore, it is stable. This carbon, if you see, this carbon is having only 3 bonds. So fourth valency, for fourth valency, it is having another bond with some other species. Okay, like this is there. Now we will write this one in a condensed formula. This carbon, left side carbon is having 3 hydrogens. Therefore, we will write CH3. This single bond we will write. This carbon, right side carbon is having 2 hydrogens. Therefore, we will write CH2. This right side bond we will write. So this C2H pi we have written in these 2 forms. Okay. Now, what is the name of this C2H pi that we will see? In the C2H pi, number of carbons 2. Number of carbons 2 means that name is eth. Alk name is eth. Therefore, the name of this compound is what we can say in the sense ethyl. Ethyl and bond we have to give. Okay. For this ethyl also abbreviated form it will be given. What is that abbreviated form? Means first 2 letters. First letter we will write in the capital letter, second letter small letter hyphen. Like this also we will write. This ethyl we will write it as ET. Like this methyl also we will write it as first 2 letters. What is that? First letter capital M, second letter E, ME also we can write. Okay. So N is equal to means ethyl we said. Next we will see N is equal to 3. N is equal to 3 we will see. N is equal to 3 in the sense, substitute N is equal to 3 here. This N is equal to 3 here, you substitute it, you will get formula and N is equal to 4. Like this we will go. Okay, continuation we will see later for this group. For this group continuation we will see later. Okay, next in the organic compounds we will take one group. Another group we will take. Already we discussed alkyl is separate. Now we will take one group. This group name is what in the sense alkane. This group name is what in the sense alkanes. This alkanes, in the alkanes, what is the general formula in the sense? General formula in the sense that is CnH2n plus 2. In the organic compounds, one family is called alkanes family. For alkanes family, what is the general formula in the sense CnH2n plus 2 we can say. Just you see previous case alkyl. What is the general formula? CnH2n plus 1. That remaining 1 here hydrogen in this case. Okay. If we give some other, you will get something. Some other compound we will get. Okay. So alkanes general formula CnH2n plus 2 we said. Now we will substitute N is equal to 1. We will substitute here N can take in the organic compound CnH2n like this is coming in the sense N will be natural numbers only. So N is equal to 1 we will substitute. What we will get we will see. We are getting CH4. N is equal to 1 if we substitute we are getting CH4. Now this CH4 will take, carbon will take 4 hydrogens are there. 4 hydrogens will take like this. 4 hydrogens we have taken like this. Hydrogen form always single bond. Hydrogen forms. Hydrogen means it will form only one bond. More than that, it never. Why it is forming only one bond? Because it is having only one electron. Its atomic number is 1. It can form only one bond. Okay. So we have written CH4. What is the name of this? What is the name of this CH4? We'll see. First, we will see alk. This alk in the sense number of carbons. How many carbon is there? One carbon. One carbon in the sense what we have to say? Meth. Then what is the suffix is there in this one? Ane. That ane you write as it is. Therefore, what is the name of this one in the sense methane we can say. So methane formula is what? CH4. Next n is equal to 2 we will take. Substitute n is equal to 2 in this general formula. We are getting C2H6. This we will write in the structural formula. We will write here 2 carbon atoms are there. Those 2 carbon atoms we will write. Here in this alkanes, this ane word is there. What is the meaning of this ane? What does it mean? This ane indicates carbon-carbon single bond. This ane indicates a carbon-carbon single bond. Between carbon atoms, single bond should be there. That's what this ane indicates. Okay. So this ane indicates a between carbon atoms, what is there? Means single bond is there, we are saying. Okay. So in this C2H6, this C2H6 coming under this category, it is coming under alkanes family. This ane tells that between carbon atoms, single bond is present. Okay. Now 6 hydrogens present. 6 hydrogens will split and will give 3 hydrogens to the left side carbon and remaining 3 hydrogens to the right side carbon we have given. Now hydrogen can make single bond, that we know. So we are giving the bonds. Now we are seeing the carbon. How many bonds it is having, we are checking. This carbon is having 4 bonds. Valence of carbon is 4. Therefore it is satisfied. This carbon is also having 4 bonds. So this valence is satisfied. That means this molecule, in this molecule, each atom valence is satisfied. Therefore, it is called a saturated molecule. We can call this as a saturated molecule. Okay. It is hydrocarbons. Therefore, we can say it is a saturated hydrocarbons. So this alkanes coming under which category in the sense saturated compounds. Okay, saturated compounds we can say. Now we will write this one in a condensed formula. This carbon is having 3 hydrogens. That 3 hydrogens we will write like this. Then the single bond we will write. This carbon is having 3 hydrogens. That 3 hydrogens we will write like this. Now we will say the name of this one. In this molecule, 2 carbon atoms are there. Alk name for 2 carbons is eth. Alk name for 2 carbons is eth, and carbon-carbon single bond is there. Therefore, ane. So name of this compound is ethane. We can say. Okay, it is as per IUPAC nomenclature. It is as per IUPAC we are saying. Okay, ethane is the name for this compound we say. Okay, next n is equal to 3 we will take. N is equal to 3 we will substitute. Then we will get C3H8 we will get 3 carbon atoms are there. Those 3 carbon atoms we will write here, and it is coming under this category. Ane in the sense between carbon atoms we have to give single bond, and hydrogens are there. Hydrogens how to split and give means for this carbon 3 and right extreme carbon 3, this middle carbon 2. Middle carbon give 2 hydrogens only. Why we will see. This carbon is having already 1 bond with this carbon, so remaining 3 bonds with 3 hydrogens. This carbon is already having 2 bonds with the neighboring 2 carbons, so it has to form still more 2 bonds. Therefore, it is forming 2 bonds with the 2 hydrogens. It is forming 3 bonds with the 3 hydrogens. Okay. Now we will write condensed formula. This left extreme carbon is having 3 hydrogens, that we are writing as CH3. This middle carbon is having 2 hydrogens, that we are writing as CH2. This right extreme carbon is having 3 hydrogens, that we are writing CH3. Now this compound contains 3 carbons, therefore we can say prop, and carbon-carbon single bond is there. Therefore, AN we are saying. Therefore, this molecule name is what in the sense propane we can say. Next, we will take N is equal to 4. N is equal to 4 in the sense C4H10. In the general formula, CnH2n plus 2, in the general formula, you substitute this. So, we are getting what in the sense C4H10, we are getting this C4H10. For this, how many structural formula possible we will see. This we will write, it is in a condensed form, it is there. This we will write in a structural formula, we will write 4 carbon atoms, we will write like this. 4 carbon atoms we have written like this. Between carbon atoms we will give single bonds, we will give, and the 4 carbons we will write in another manner now. That 4 carbons how we have written in the sense like this we have written. Okay, here single bonds we will give. Single bonds we have given. Okay, that arrangement of carbon atoms we have varied practically like this existing. Okay, arrangement of carbons we have varied practically like this existing. Then we will give hydrogens. This carbon is having one bond, therefore it has to make 3 more bonds with 3 hydrogens. This carbon is having 2 bonds left and right, and therefore it is in need of 2 more hydrogens. This carbon is making 2 bonds with the 2 hydrogens. This carbon is making 3 bonds with 3 hydrogens. The condensed formula we can write CH3, CH2, CH2, CH3 we can write. For this carbon we will give 3 hydrogens, we will give. For this carbon 1 nitrogen we have to give because already 3 bonds are there. For this carbon 3 hydrogens we will give. For this carbon we will give 3 hydrogens. Therefore, what is the formula in the sense? This is CH3, single bond CH, CH3, CH3. Like this we have written. Okay. So this molecule we have written like this we have written. Okay. Now, so for C4H10, how many structures possible? See, 2 structures possible. This is one molecule, it is another molecule. This molecule molecular formula is C4H10. This molecule molecular formula is C4H10. So these two molecules have same molecular formula, but structures of these two molecules are different. Therefore, we have to call these two as structural isomers. We have to call structural isomers. We have to call. What is iso? This iso indicates this isomers. In that isomers, iso indicates say. What is isomers? Isomers in the sense they have same molecular formula. Isomers in the sense they will have same molecular formula, but difference in properties. Which properties? Chemical properties and physical properties. Okay. So what is isomers? Isomers means they have same molecular formula but have different properties. Properties in the sense physical properties and chemical properties we can say. Next. In the isomers, one category is structural isomers. What is structural isomers? Structural isomers means they have same molecular formula but different structures. Structures will be different. That is called structural isomers. Now see, this molecule and this molecule is having different structures. Therefore, these two molecules are called structural isomers. We can call these two molecules as structural isomers. We can call. So, now these two molecules we are calling that structural isomers, we said. So, now practically if you see these two molecules are existing, these two molecules are having different properties. These two molecules are having different properties practically. Practically, experimentally, it is possible. Actually, these two molecules are having different properties. So, now, how to say the name for these two molecules? What is the name for these two molecules? That we will see as per IUPAC nomenclature. as per IUPAC nomenclature, what is the name of these two molecules? That we will see. Okay. IUPAC nomenclature says, name of organic compound contains one word prefix, then root word, then primary suffix, then secondary suffix. IUPAC nomenclature says that name of organic compound contains like this: prefix, root word, primary suffix, secondary suffix. What is root word? What is root word? That we will see. What is root word? Root word is nothing but root word. If you want, first you select parent chain in the organic compound. Root word we have to say from parent chain. What is parent chain? Parent chain is called longest continuous carbon chain. Okay, parent chain means what? Longest continuous carbon chain is called parent chain. So what is parent chain? We got longest continuous parent chain. That means the chain, carbon chain. Carbon chain means this chain should contain carbon atoms. Carbon chain means this chain should contain carbon atoms. How this chain should be there? Longest and continuous. Continuously the chain should be there. There should not be any discontinuity. Okay. So now we will select a parent chain in this molecule. In this molecule, we will select parent chain. This is the parent chain in this molecule. This parent chain contains 4 carbons. In this molecule, parent chain contains how many? Means 4 carbons present. Now we will take this molecule. In this molecule, what is the parent chain? Means this is the parent chain. Okay, in this molecule, parent chain is this. So the parent chain contains 3 carbons. So in this molecule, parent chain contains 4 carbons. In this molecule, parent chain contains 3 carbons. In these two molecules, number of carbons in the parent chain is different. Therefore, these two molecules are called chain isomers. What is chain isomers? Chain isomers means they should have same molecular formula. They should have same molecular formula. They should have different structures. They should have different structures. They should have different number of carbons in the parent chain. They should have different number of carbons in the parent chain. Number of carbons different in the parent chain. Okay. So what is chain isomers? They should have same molecular formula. Okay. These two are having same molecular formula, that is C4H10. They should have different structures. Yes, this structure and this structure different. They should have different number of carbons in the parent chain. Yes, this parent chain contains 4 carbons. This parent chain contains 3 carbons. Therefore, number of carbons in the parent chain is different. Therefore, these two are chain isomers. Sir, okay. Now we will go for this root word. Root word means that root word will be said based on number of carbons in the parent chain. Okay. So root word is what? Root words is said based on number of carbons in the parent chain. So we have to say the root word based on number of carbons in the parent chain. If number of carbons is 1, then root word is meth. Okay, that means number of carbons in the parent chain is nothing but alk. If number of carbons in the parent chain is 1, the alk says meth. Number of carbons in the parent chain is 2 means the alk says eth. Okay, so now we will see this molecule. For this molecule, parent chain contains how many carbons we know. This is the parent chain. The parent chain contains 4 carbons. We said 4 carbons in the sense the root word is but. Root word is but. That means root word in the sense alk. Root word in the sense alk. So this parent chain contains 4 carbons. Therefore, root word we are saying what in the sense but we are saying root word we are saying but. Okay. Next, for this we will see. For this compound, parent chain contains 3 carbons. Parent chain contains 3 carbons in the sense what is a root word that we will see here CH3, CH3, CH3. It is a parent chain. This parent chain contains 3 carbons. Therefore, root word is what in the sense prop. Okay. In this molecule, this is a parent chain. This parent chain contains 3 carbons. So parent chain contains 3 carbons. Therefore, root word is what in the sense prop we can say. Root word is prop we can say. Okay. So we completed what is root word we have completed. So next we will see root word is completed. Next prefix. Prefix in the sense. Prefix means the group which comes under which is away from parent chain. Okay, the group which is not present in the parent chain only will come under prefix. The group which is not coming under parent chain is there means then only we have to say prefix is there or not we have to say. So, which will come under prefix that we'll see. Okay, which will come under prefix. Prefix in the sense substituent will come under prefix. Substituent will come under prefix. What is substituent? Substituent means one example is alkyl. One example. Still more are there. Many things coming under substituents. Substituent only will come as prefix. In that we said alkyl we said. Alkyl in the sense CnH2n plus 1. Okay. This should not be in parent chain. It should not be in parent chain, but it should be linked with the parent chain. Linked with the parent chain. Okay. It should be linked with the parent chain. It should not be in parent chain. It should be linked with the parent chain. Like this should be there. Okay. So now we will see. Is there any group away from parent chain? All the atoms are in parent chain. Nothing is away from parent chain. Therefore, in this molecule, prefix is not there. In this molecule, there is no prefix. Now we will see this molecule. In this molecule, parent chain contains 3 carbons. What about this? What about this? What about this group? This group contains CH3. This group contains 1 carbon. Is it present in parent chain? Is this carbon present in parent chain? No. This carbon is not present in parent chain. This CH3 group is not present in parent chain. This CH3 group is linked with parent chain. Therefore, it is coming under prefix. We know CH3 name is methyl. So here prefix is there. For this prefix is there. Okay. So for this compound we said root word we said. Now we are saying prefix. What is the prefix in the sense methyl is the prefix. Methyl is the prefix. For this compound prefix is not there. For this compound prefix is not there. For this molecule there is no prefix. For this molecule prefix is there. Okay. Next we will say this primary suffix. This primary suffix will tell about what? Primary suffix is telling about between carbon atoms single bond is there, or between carbon atoms double bond is there, or between carbon atoms triple bond is there. That's what primary suffix will say.